Hello guys, welcome back to Manala's Arc, and in this video we want to learn about trig functions. So by now basically you know about the other types of functions: linear function, parabola, hyperbola, and exponential graph. But then it doesn't end there. We have things like the trig function. Now let me check the following thing here, just to make sure that first of all my video is recording. Boom boom boom. Yeah, that is okay. Let me put that here. And also to make sure that my video doesn't have a blue light filter, right? Because of sometimes my video can turn out to be dark because I use a blue light filter too. Yeah, I just keep on using blue light filter. Okay, that's that. We are sorted now. So here we have different types of trigonometric graphs, and of course when we say trig graphs, those graphs are going to be a sine graph, we are going to have a cosine graph, and we are going to have a tangent graph, I meant to say. So here, let's get to it. What happens is that in these graphs, the graphs we are going to work with, it's the graph that says the sine of theta. No, this is not an equation of a graph. A graph must have an equation. So we're going to say y is equals to the sine of theta. You must be able to plot that. Let me reduce some thickness there. You must be able to plot a graph that says y is equals to the cosine of theta. And you must be able to plot a graph that says y is equals to the tangent of theta. Now this is different because of usually when we work with graph, we just say y is equals to 2x plus 1, and we know how to plot this because on the x-axis and on the y-axis you use those coordinates to plot your things. But then here now we're talking about theta, we're talking about y, we're talking about sine. Now how do all these things affect everything, right? So we usually know that normal graphs that we know, either it's a straight line or it's a parabola or it's exponential or it's a hyperbola, right? Remember these graphs. So but then now once it starts carrying on trigs and sines and cosines, tangents and things like that, how does it affect everything? I want you to understand now that when we talk about this type of graphs now, we are going to work with these things. What do they call them? Waves, cycles. Your graphs are no longer usual graphs now. Some things that are like this. They keep on forming waves, right? They keep on forming waves, regardless of how you see the wave, right? Regardless of how you see the wave. And believe it or not, there's a mathematical formula that helps you to plot these things. Can you believe that? There's a mathematical formula that has a method that makes us plot some things like this, right? Now let's see how is that possible. We start with the most basic one, the sine graph, right? Here's a Cartesian plane here, and then I want to say to you that you see, when we are working with a sine graph, the sine graph will move like this way on a Cartesian plane. This is your y-axis, this is your x-axis, right? But then this is the theta point. Now, that's the main difference. Here's what happens. Whenever you have equations like this one, your y values will take the vertical axis and your theta values will take the horizontal axis. Now, this point here, always, this is the point of everything being 0, right? And then now the last point in this case is going to be 360 degrees. Now, can it go past 360 degrees? Yes, because you can see there's an arrow here, right? And then halfway mark, it's how much? What is the halfway point? You would have guessed it's 180 degrees. And then the in-between point here, it's how much? That is 270 degrees. And then here, the in-between point, it's how much? That is 90 degrees, right? So you can label this thing anyhow, but usually these are the basic values we use, right? So now, and then here we have our y coordinates. Your y coordinates, let's put two values here. We have the 1 and 2. Your y values here, you have your -1 and -2. Can the values increase or become more than this? Yes, they can. So for grid 10, usually you work with graphs that are on the positive side of this Cartesian plane, right? Most of the times you work with graphs that are on the positive side of this Cartesian plane. So now, I want you to cram a Cartesian plane for a trig function, all trig functions to be this way. This horizontal line, it no longer works with x values. Basically, it works with your angle values, your thetas. This is 90 degrees, 180 degrees, 270 degrees, and 360 degrees, right? So now getting to a sine graph. A sine graph, its general equation it is y is equals to a sine theta plus q. Hope you see me there. And this only works for grade 10, by the way. Don't worry about grade 11 things or other things that you find on the internet. I'm teaching you things that will work for you this year. And then next year, I'll reteach you proper things, right? So grade 10, this is what you have. And then the mother graph of a sine graph, which means we are saying the simplest graph we can ever find of a sine graph. The mother graph of a sine graph is y is equals to the sine of theta. This is the simplest graph of a sine graph you can ever plot, right? So now what happens with that graph? That graph now, it's going to be as follows. We need a table here, right? So I'm going to put a table for my theta values and see how much will I get for y. Now, as we know, with any function that we have to plot, we need a table, right? So this is my table. Y is equals to the sine of theta. Now, this is the theta and this is my y. Let me use a black pen here on the graph. Or maybe a red pen. It's more visible. It's visible everywhere. So this is my theta and this is my y. Y is equals to sine theta, right? So now take out your calculator and see if you can find these values. Here we will have this point here, 0 degrees, and then here we will have the point 90 degrees, and then here we'll have how much? 180 degrees. Here we'll have how much? 270 degrees. And then here we'll have 360 degrees, right? I want to know how to plot this graph. Now, the values here, the sine, when theta is 0, I'm going to say the sine of theta, right? Let me take out a calculator and do the first two, and the other ones I'll skip to fill them in. So the sine of 0 degrees is how much? That is 0. So the sine of 0 is 0. So which means here I will write 0 degrees. We all see that now. And then the sine of 90 degrees, it gives me how much? 1, right? So which means here I will put in how much? 1, right? And then let me fill in the rest here. You see that? Now the whole table is filled by substituting all the values on the calculator. And then now I'm going to plot these values on the Cartesian plane, right? So here, here's what I have. When theta is 0, my y is 0. So when theta is 0, my y is 0 there. The next part, when theta is 90 degrees, my y is how much? My y is 1. So right there, there we go. The next part, when theta is 180, my y is how much? My y is 0. There we go. Then when my theta is 270, my y is -1. Here we go, -1. Then when my theta is 360, my y is 0. There we go. So now this graph more or less moves like this. There we go. This is a sine graph. Beautiful. Perfect. You see that? So this is all you have to know about a sine graph. This is the mother graph, the simplest sine graph we can ever find, and this is how you plot it. Easy, right? So then there are several things that you have to know. And those things, we call them characteristics of a trig graph. Let me write that down. Characteristics of a trig graph. So now when we talk about characteristics of a trig graph, we talk about the following. We talk about the amplitude. We talk about the minimum value. We talk about the maximum value. And we talk about the range. See that? Now, when we talk about the amplitude, we are talking about the graph from the point of rest up until the highest point there. You see that? The distance from the starting point of the graph to the highest point of the graph, that is the amplitude. So the amplitude in this case is how much? It's 1. You see that? Easy. And then we talk about the minimum value. Here we talk about what they're asking you here. They want you to give us the lowest y value for this graph. So the lowest that this graph can go, it's up until here, up until this point here. Right? And what is the y value at that point? The y value is -1. So our minimum value is -1, right? And then they'll want you to tell us about the maximum value, which is the highest point of the graph, and the highest point of the graph in this case, it's this one. And how much is that? That is 1. So that is 1. And then they also want to know the range, right? In this case, the range, you write it in a form of it said builder notation. Yeah. The range, let me write it here, is, we're going to say y is an element of, you tell us the lowest value that this graph can touch, which is this point here. So we are going to say it's how much? It is -1. Then you give us the highest value that this graph can touch, which is here, +1. Now this is your answer for the range. Now rewind the video, see if you can do all the things that we spoke about here for the sine graph. Try to do that. Rewind, try to see if you can spot all the things we spoke about for the sine graph. Now let's talk about the cosine graph. The cosine graph, first you'll need to understand its general equation. The general equation of a cosine graph is that y is equals to a cos theta plus q. That's the general equation. And the mother graph, here we are talking about the simplest equation of a cos graph, that is y is equals to cos theta, right? Now let's say there's a question that says plot this graph for me, plot the mother graph for you. We do the same thing that we did here. We need a table for that, right? So let me design a table for you. Here's the table, and then now we need to do the annotations, right? We know that this point, that's where you have 360 degrees. Halfway point, that's where you have 180 degrees. And then between 180 and 360, you have 270 degrees. Between 0 degrees and 180, you have 90 degrees. And then we know that your y coordinates, we don't need a lot. We have 1, we have 2, we have -1, and we have -2. Remember we said the left side of the Cartesian plane for grade 10, we don't need it. Now on to the table. This is y is equals to the cosine of theta. Let's use a different color here so that we can see. And then here we know that we have our theta. Here we have our y is equals to the cosine of theta. Then here, these are our values. The 0 degrees, the 90 degrees, the 180 degrees, 270 degrees, and the 360 degrees, right? Then now we do the plotting, substitution, how I taught you with the calculator, right? So I'm just going to get straight to it. There we go. All values fitted in the table. And then now we do the plotting. Remember to label your graph. This is the y, and this is the theta point, right? This is what your theta is. So when you have 0 degrees, for the horizontal plane, you have 1 for y. So which means this happens at the y-intercept. When you have 90 degrees, you have 0 for y, which is this point. I hope you know how to plot graphs. Then when you have 180 degrees, you have -1. Here's -1 and 180 degrees. This is the point of convergence. And then when you have 270, you have 0 degrees. Oops, hope that's visible. And when you have 360 degrees, then you have 1 again, somewhere here. Right? Then when you plot this, it becomes more or less like this. Right? This is what I wanted. But then remember, when you plot the graph, you're not supposed to have a sketchy line. So let me fix this. It's not supposed to be a sketchy line. It's supposed to be a more like perfect line. This thing is refusing, guys. I'm trying. And something like this. This is how far I'm willing to go. Yeah. So this is a cosine graph, right? So now to answer the same questions again with this cosine graph, we focus on characteristics of a Trig graph. I wish I could have used a proper color there, but let me use it now. Right. So first things first, what do you need to know? You need to know the amplitude. We said what is the amplitude? Now let me teach you a proper definition of an amplitude. The proper definition of an amplitude, it says this is half the maximum value minus the minimum value. You still remember what are maximum and minimum values? I hope you do. Let me remove this table here so that I can create more space for us. Here we are. Now, for us to do that, we need to know what is the maximum value, which is one of the characteristics, by the way. We need to know what is the minimum value. Right, to answer that, the maximum value is the highest point of the graph at any point, right? So here and here, the highest y value is 1. So that is the maximum value. So our maximum value is 1. The minimum value is how much? It's the lowest point of the graph. So here's the lowest point of the graph in which y there is -1. So -1. There we go, right? Another thing, I'll get to amplitude. Another thing we need to know is what? It's the range. And then we set the range, you write it as an interval. You're going to say y is an element of, you mentioned for us the lowest value. What is the lowest value for what? It's -1. What is the highest value for y? That is +1. So this is the range. We good? Now, back to the amplitude. The amplitude, we said it's half the maximum value. What is the maximum value? That is 1. Minus the minimum value. What is the minimum value? -1. Right? This gives us half of 2, and half of 2 is the same as 1. So I think it's best you learn it with the formula, because sometimes they might ask you this for 2 marks, and you giving us an answer alone won't get you 2 marks. Good. So that's how we do it. Cosine graph done, sine graph done, right? But not really. We can get to the intricate details of these things. Of course, we have more details on these things. Here I have the concept of the change in amplitude. So in this case, when we talk about the amplitude, we talk about the following. I want you to look at this one here. Here, I want to work with the graph of y is equals to a sine theta, right? And then here, I want to work with the graph of that's not an a. I want to work with the graph of a cos theta. Now, I guess you can see what's happening here. I've introduced this variable a, right, in both sections. So in this Cartesian plane, I'll plot this graph. In this Cartesian plane, I'll plot the graph of a cos theta. But then first things first, I want to plot the graph of the mother graph, which is the cosine of theta, right? Afterwards, same thing applies here. I want to plot the mother graph, which is the sine of theta, right? Afterwards, I want to plot the graph of, let's call this g of x. I want it to be 2 sine theta. You see then, at first here we had nothing, and then here we have 2. And then here, let's do something different. Here for p of x, let's say I want to plot the graph of 4 cos theta. And I want you to see how this a affects the graph of the cosine of theta. Same thing applies here. I want you to see how this a affects the sine of theta, right? So let's start with the sine graph. The sine graph, when you plot its mother graph, this one, you first know that this ending point, it's 360 degrees. The halfway mark then is 180 degrees. Between halfway and the end point, you have 270 degrees. And between the initial point and that, you have 90 degrees here. And this is 0, right? And then here, you know that you have 1 and you have 2. Remember, this is not limited to 2. It can go as far as possible. And then here we have -1 and -2, right? So the sine graph, the mother graph, the simplest sine graph, how it flows, we know that. Let's wait for this to load. Quick. I have to keep on saving because otherwise I'll lose all my notes. This thing keeps on crashing. So the mother graph of a sine graph, we know that it moves from here to there, to there, to there, to there, right? According to how we plotted it somewhere here, right? So let's do that again here. We are saying that I know that this will move. When I have 90, I'll have 1. And then I'll have this coordinate here. When I have 270, I'll have -1. And I'll have this coordinate here. So more or less at 0, when theta is 0, y is 0. So more or less this graph moves. Let's remove this. It's somehow. Let's remove this. Let's try again. This graph will move like this, then like this. Let me stop here. Then it will continue like this. Boom! I tried. You can see that that's a sine graph. It moves like a wave this way, right? So now, and then if this is the basic graph, this is the graph of what? Y is equals to the sine of theta. Then I have to draw this graph now, this one, whereby I now have the amplitude. This part here, it represents the amplitude. The a in front of the trig function represents the amplitude. So this will mean what now? It means the distance from here to there, it now has to be 2. Right? The distance from here to the lowest point, it has to be at -2. And now that's the graph. And then here, this point of rest doesn't change. It's not affected by that. So this graph now, it will move this way. Oh, let me fix that. It's not perfect. Right here. There we go. Now, this is the graph of g of x being equals to 2 sine theta. That's it. That's the only difference, is that the amplitude now moves to 2. It's no longer 1. Here, the reason the amplitude is 1 is because in front of sine, we know that there's an invisible 1 now, which means its amplitude is 1. And now, if the number in front of sine is 2, it means the highest point this graph will ever reach, it's 2. And the lowest point it will reach, it's -2. Hope we see that. Now, let's move to the cosine. To the cosine, same thing here. I know that my endpoint is 360 degrees. I know that the halfway mark is 180 degrees. And then here I have 270 degrees. And here I have 90 degrees. There we go. Let's say 1, 2, 3, 4, because I know I need 4. 1, 2, 3, 4. So this is 1, 2, 3, 4, and here I have the negative ones. There we go. This is my y-axis, and this is the theta plane, right? So according to a standard cosine graph, what happens? This matter graph of cosines, remember what we had here, something like this, right? The highest point it will reach its 1, the lowest point it will reach its -1, and then here that's where it crosses there, right? So same thing has to apply here. Let me save this. Let's wait for it to load before it crashes. I'm sorry for this inconvenience, guys. It's almost there. Bingo. Now here we were saying, in this case, I know that the basic graph, the highest point it's there, it will cross there, and then the lowest point will pass there, and it will get back there, and then it will be somewhere back to 1 this way. So basically this graph will move like this, right? Let's remove that. Something like that. I hope you see it. It won't be perfect though, because I'm using a writing pad to draw those things. But then yeah, basically that's what we have. Now this is the graph of y is equals to the cosine of theta. Now if I modify that, if I add an amplitude now, a number in front of the cosine, it means now the amplitude is no longer 1, it has to be 4. So which means here, let's choose a proper color. The starting point of this graph, it will be here at 4, and it will still for some reason cross there, but then the lowest point now it will be at 4. It will still cross there, and then the end point will have to be somewhere there at 4. So which means this graph now, it will move more or less like this. That's how this graph will be affected. Now, what happens is that sometimes they will ask you a question about, oh, I forgot to label this graph here. I'm already moving on. I have 2 labels. This graph, we're calling it the P of X. P of X is which part? Is the part whereby we have 4 in front of the cosine of theta, right? And then, so now, the next part here, what happens is that sometimes they may ask you to reflect the graph on the horizontal plane, on the horizontal axis, sorry. So let me remove all this. I'll only do one part, and then I know you'll figure out the rest, right? So this is a video, guys. I don't have to do one example twice. I only do one example once, and if you want to see it twice, then you'll just reverse and look at it again. So here, let's say there's a question that says reflect g of x on the x-axis, let's say, or on the horizontal plane, right? Along, yes, the term here is supposed to be along. Reflect g of x along the x or the horizontal axis, right there, which means this graph here that we see g of x, when they say reflected along the thing, this is what you have to do. You have to see that if I put a mirror here, basically what I'm going to see is that this part here will now appear on this side. So which means I'll have this thing moving this way. Am I doing that properly? I'm trying. So this graph, this blue graph, it's a reflection graph, right? Hope you accept that. So which means this red graph, if I put a mirror here, it will appear here now, right? And I'll call this g of x prime, right? And then it will become this way and this way. Now what happened there? What will be the equation here? Because of here my amplitude was 2 and it went up until there. Now my amplitude, now that it started by going downwards, it's -2. Then that's the sine of theta. See that? Hope you get that. I hope you see now that if you get a graph that has a negative amplitude first, it means you don't go upwards, instead you go downwards. Then it moves on like that. We're good. So I'll pass on from that. Pass on. It's a weird term. Oh, before the tangent, there are some things we have to do here. The vertical shift. So now, the other part that we have to talk about now, it's the vertical shift. So on this equation, y is equals to a sine theta plus q from the general equation. We spoke about this part and we understand how to plot this part. Now we have to talk about the q, the vertical shift. So here, the graph of y is equals to sine theta. It's already here, it's plotted, right? Now, if ever I'm to say, plot for me the graph of y is equals to sine theta plus 2. What do I want there? It means everything you see in this graph, I want you to move it by 2 units, right? I hope it makes sense. Let me not say plus 2 because I don't have enough space. Let me just say plus 1. Plus 1, right? So what will that do? This will cause me to take this coordinate, move it here once. Take this coordinate, move it here once. Take this coordinate, move it up once. Take this coordinate, move it up once. And take this coordinate and move it up once. Now this graph now will look like this. Now this is the equation. Y is equals to sine theta plus 1. Do you see the effect? Now if you see the graph that is already like this one, the orange one, just know it's a normal sine graph, just that it was moved upwards by 1 unit. The vertical shift. We call this the vertical shift. Right? So let's do this one now. Here we have, but I bet you can do it on your own. Here we already have the graph that say y is equals to the cosine of theta. It's already plotted. Now the next part, let's say they want you to plot the graph of y is equals to negative, sorry, not negative, it's going to waste time, this one. So let's say it says the cosine of theta minus 2, right? I want to plot this one now. So which means from the normal cosine graph, I have to move where? Downwards. How many units? 2 units. So which means I have 1, 2. This will be the coordinate. This one is what? 1, 2. So this coordinate will be here. And this one is where? 1, 2, which means it will now be here 3. This coordinate it's 1, 2, which means it will now be here. And this coordinate will be 1, 2, which means it will be here. So now this graph is this way. See what happened to the graph? It has been moved vertically downwards. So now on the situation whereby you have y is equals to a and the cosine of theta plus q, we know how to plot the cosine of theta. We know how the a is the amplitude and how does it affect the graph. And we know how q is the vertical shift and we know how it moves the graph. All set. Now we have to go to the different type of a graph, which is the tangent graph. Oh, again, before the tangent graph, I want to add one characteristic that I forgot here. The characteristics of a Trig graph. So we spoke about the amplitude, right? Let me put that. Spoke about the amplitude, we spoke about the maximum, the minimum, and the range. Now there is something that we forgot, that is the period. The period of the graph, we are talking about the amount of degrees we need to form a full wave of the graph, right? What is a wave? When I have the starting point, the graph moves and then it gets back to the starting point then that's a full wave, right? Let me clear some space and create that concept for you. So here, in this case, if this is a Cartesian plane, a graph moves and it ends here, right? This is a full wave, and usually this happens where? At 360 degrees. Now, if we extend this Cartesian plane, we're going to get multiple waves. This graph will move on like again and get there. This is the second wave now. And then it will move on like that and get to the third wave. So this point here, it marks the first complete wave. This part here marks another complete wave. So to move from here up until there, that's a full wave, right? So look at that. You see that? From here up until there, it's a full wave, and it takes us how much? 360 degrees. So to move from here to there again, it will take us another 360 degrees. So that's what the period is asking you. It's asking you that for you to get a full, complete wave, how many degrees do you need? We need 360 degrees for this graph of a cosine graph, because it starts here, it ends there, and if it was to continue again, it will look like this again and then like that again. So this is a full wave of a cosine graph. This will be another full wave of a cosine graph. You see that? So the period of a cosine graph is 360 degrees. And then for a sine graph, look at that. We just spoke about it. See, for it to move from here back to there, it takes us 360 degrees. For it to form another wave, it's 360 degrees. Now, to the tangent graph. The thing about the tangent graph now is that for it to form a full wave, it doesn't really need, 360 degrees. So we have different cycles. The first cycle is the cycle of asymptotes. Cycle of asymptotes. And then we have a cycle of waves. Cycle of waves. Right? So first of all, to start with the cycle of asymptotes, here we are going to have, here they are. You see that? So these things that you see here, these dashed lines, we call them asymptotes. These are the points that a graph will never touch. And then unlike the cosine graph that moves, a sine graph that moves like this, or a cosine graph that moves like this, the tangent graph moves differently compared to these ones here. Instead, the tangent graph will move in this way, and it will form another wave like this, and another wave like this, and another wave like that. Hope you get what I'm saying. So it keeps on forming waves. Let me see if I can get a picture for you for a tangent graph. Here is a picture of a tangent graph. You see how it moves. You see all those waves that are moving there. This is how it looks. Unlike the sine graph that looks more or less like this, or the cosine graph that looks more or less like this, the sine graph will look like this. The tangent graph will look like this, making its waves like face upwards and downwards this way. You see that? So now, for us now to quickly plot this graph, you can use your calculator and form a table. At this point, you know how everything works, right? I'm just going to draw the shape for you. This graph is going to move like this, approach the asymptote but never touch the asymptote. And at this point, it will move like this on this part, and then it will move like this on this part, right? And then here it will move like this. So what are we realizing here? We're realizing that this is the top half of the graph and this is the bottom half of the graph. And on a Cartesian plane that starts from 0 degrees to 360 degrees, we actually see one full complete wave, and then we see half a wave to the upside and half a wave to the downside. You see how it looks? Yeah. So basically this is how it looks. And then we have things like the concepts of A and Q to the graph, right? So we need to find out How is A affected? How is Q affected? We see that. So now let's get to that. Oh wait, before I get to that, there is one thing I forgot. Characteristics of a trig function or a trig graph, right? So always learn how to answer characteristics. First of all, what is the maximum value? What is the highest y value this graph will ever reach? So on the y values, it will keep on going up, up, up. We don't know where it will stop. So we'll just say positive infinity, right? And then what is the minimum value? What is the lowest point this graph will ever reach, right? So I'm sure you would have guessed this graph will keep on going down, down, down. So we'll just say up to negative infinity, because we don't know how far will it take this graph to get there, right? And then another characteristic, this way it keeps on showing me, it is the range, right? So this graph, the range. Now remember, now the range has to be written as an interval, right? So I know that my y value is an element of, and then I make a curve bracket this way, because it doesn't actually touch that point that I'm about to mention now. So the lowest point that this graph can ever move from is negative infinity. The reason I'm making a curve bracket and not a square bracket is because this graph gets closer to infinity, but it never touches infinity. Nothing can touch infinity because of infinity. Okay, you know why? Infinity is just an idea. It's not a real destination. It's not a real number or a specific value. And the range of this graph, it will end where to positive infinity, and we make a curve bracket again because it doesn't touch positive infinity. Sorry, yes. And then we have the amplitude. Now, if there is one thing we know about the amplitude, it's the formula, right? The formula says maximum value minus minimum value, right? But then this is us basically saying infinity minus infinity, right? That is not really possible, right? Yeah, it's infinity minus negative infinity. So that is not really possible. Infinity is not a real number. And you know, when you calculate real numbers, you get error. So we are saying this thing has no amplitude. You see that? Beautiful. And then we have the period, the one that we forgot for other graphs. The period. The period, we're saying it's the amount of degrees it takes this tangent graph to make one full wave. So we know that we can see a full wave here starting from 90 degrees to positive 270. How many degrees is it for us to move from 90 to positive 270? That is 180 degrees. So unlike all the other graphs, a tangent graph only takes 180 degrees to form a full wave. You see that? Now let's move on to the next part. So we are saying here that we already know that the tangent graph will look this way, right? A normal tangent graph. So it will move this way. I want you to look at this point. At 45 degrees, the graph is equated to 1. And also here, at 135 degrees, which is the midpoint of 90 and 180. At 135 degrees, the graph meets -1 on y. The point of inflection is here at 180. And then another point, it's the point of 225 matches with 1 on y. So I want you to check those highlighted coordinates, just those highlighted coordinates, and see the effect of us having y is equals to a and the tangent of theta plus q. All set. So in this case, here's what we have. Let me use a red color there. I don't know, 1 point. If ever I have a graph of y is equals to twice the tangent of theta, right? Because of what you are seeing here is y is equals to the tangent of theta. Now, if here I have 2, what will happen? It means here, this 45 degrees will no longer match with 1. Instead, it will match with 2. And this line will move like this. Same thing applies here. This one will no longer match with -1. It will now match with -2. And this part will no longer match with positive 1, it will now match with positive 2. And therefore, my graph is going to be more or less like this. It will pass here. It's hard to see these things with a tangent graph, but the more you do them, the more you'll see it. Same thing applies here. The coordinate will move past 2, and then it will go there. This way. You see that? Hope we're good. Let me do the last one. If I have a graph that says y is equals to 3 tangent of theta, what's going to happen? This point of inflection will no longer be here at 1, it will be here at 3. So which means this line is going to start from 0 the way it always does, and then I don't know how to fix that thing for you. Then it will move like this. It will start curving there. This, we call it the point of inflection. Let me write it here. Point of inflection. You see that? That's what we call it. Why? Because once the graph gets to this point, it starts curving. Same thing applies here. Once it gets here, it starts curving upwards. So same thing applies here. My dot of point of inflection will no longer be here at -1. It will be here at -3. Same thing applies here. My point of inflection will be here at +3. And then we are still going to pass here at 180 degrees. So which means we are going to have more or less what looks like a straight line. Then from here, it starts curving. Same thing applies here. It starts, oops, let me fix that. Same thing applies here. It also starts curving here, this way. Also, this part here, it's no longer going to be at -1. It's going to be here at -3. Then we move to that. Then here it curves downwards. See that? Basically, that's just that. That's the whole point of this, right? It's hard for us to call it the amplitude. It's not the amplitude in this case. It is the vertical stretch. That how will this graph be stretched vertically, right? We see that. And then we have to consider now the point of Q. Let's do that. So on a graph, on a normal graph, we have y is equals to the tangent of theta, which is what you are looking at here. And in the general equation for this graph, it says a, the tangent of theta, plus q. We already spoke about this. This is the vertical stretch. Now we have to speak about this, and this we call it the vertical or the vertical shift. Right. How does this graph move vertically? So this is the normal graph, and then if I have a graph that says y is equals to the tangent of theta plus 1, it means now I'll have to shift every point upwards. The same thing it works with cosine and sine graphs. So here, this now will be the starting point. This point of inflection, it will be 1 unit upwards. And then this graph now, it will move like this. See that? Same thing applies here. This point will be here now. This point will be here now. And this point will be here now. And then here I'll have my line. And here it will start curving this way. And here it will start curving this way. Right? Same thing applies here. This point will move upwards and this point will move here, which means here I'll have my line and it starts curving downwards. That's how the vertical shift affects the graph. Hope we're good. Hope there is nothing too difficult there. See that? Same thing. If I put +2, it means this dots will move 2 units upwards. If I put -2, it means this dots will move 2 units downwards. You see that? So another thing, graphs are not always positive, right? They can also be negative. What we are looking at here is y is equals to the positive tangent of theta. Now, what happens if y is equals to the negative tangent of theta, right? It means whatever you see, it starts by going downwards first. In fact, it's like you're reflecting the graph along the x-axis or the horizontal plane. The same way we did it. Is it here? No, it's not here. It's also not here, but I don't remember that slide. Yeah, I don't remember that slide. I think I removed it. Yes, right. So if it's negative tangent of theta, the first thing you do, instead of starting by going upwards, you reflect it downwards. It means the normal graph you have, you should reflect it downwards. That's what we want. So it means we start first by going down. So the first coordinate is here at -1, right? And then we move this downwards this way. And then here, this part, it's not going to be there. It's reflected upwards. That's what the negative does, basically. It just reflects everything. This point, if we reflect it, it's going to be here. And this graph here, it will move this way, right? This point, when we reflect it, it will be here, a unit down. And the graph here will move this way. You see that? Same thing applies here. This point will be reflected upwards, which means, and this one, we have it here. And this graph will move this way. You see the red graph? That's how it goes. So that's it about trig graphs, guys. This is how everything is affected. We spoke about this graph here plus Q. We spoke about how this is the vertical stretch. We spoke about how this is the vertical shift, right? And we saw how it affects everything. We spoke about the basic tangent graph, the characteristics, characteristics of a trig graph, the maximum, minimum values, the range, the amplitude, and the period. Same thing applies here. We also did that. And then we have this part of the cosine. And we spoke about the sine graph and how to plot those things. And back to the introduction. We spoke about everything here. So in terms of how to answer questions about these types of graphs, I have a video that I'll attach to this one so that you can see how we actually answer questions based on these things. So thank you for watching. If you haven't subscribed, please do subscribe. I realize that only 30% of my viewers or 40% have subscribed to the channel. So if you're one of them, please if you're not one of them, please do subscribe. Don't forget to like the video. See you on the next one. Goodbye.